Hey guys, today we're going to learn how to solve a right triangle. Now solving a right triangle basically means that you're going to solve for all the missing sides and missing angles. So first we have here this triangle ABC. We are missing sides X, Y, and angle A. So we can choose to solve for any of these in any order that you would like. The way that you solve a right triangle, there is no particular right way. There are many ways in which to solve. It all depends on how you see it first. I'm going to start off with solving for x. Now, if I want to solve for x, I have here the opposite side, and the x is the hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So I would write out an equation that would read sine of 39 is going to equal to the opposite, which is 11, over the hypotenuse, which is x. Multiply x to both sides. We get x sine of 39 is equal to 11. Then we would divide by the sine of 39. Once you have your equation written like this, now we're ready to put this into the calculator. So remember that your calculator should always be set to degrees. So always make sure that your calculator is set to degrees. So I'm going to do 11 divided by the sine of 39. And that gives me 17.47. Now it says here to round the side lengths to the nearest tenth. So that means that x is going to equal to 17.5. Now, we're going to solve for y. Y is the adjacent side. So I have here the adjacent and I have the opposite. Or you can use the adjacent and the hypotenuse since now we have that x is equal to 17.5. Whichever way you choose to do it is acceptable. I'm going to choose to use the 11 just because it's not a rounded number, so I'll get a more precise answer. So I'm going to use the opposite and adjacent. So that means that I would have to use a trig function of tangent. So we have that tangent of 39 is going to equal to the opposite, which is 11, over the adjacent, which is y. Multiply the y to both sides. We get y tangent of 39 is equal to 11, and then divide by the tangent of 39. So we get that y is equal to 11 divided by the tangent of 39. So I'm going to go to my calculator again, 11 divided by tangent of 39, and we get 13.58, which rounded to the nearest tenth would be 13.6. Now to solve for the missing angle A, you can do this in two ways. Now that you have all of these sides, you can use any inverse trigonometric function to solve for A. Or all angles of a triangle add up to 180. So I know that this is 90 and this is 39. So to solve for A, I can add these two together, 90 plus 39 plus the measure of angle A is going to equal to 180. 90 plus 39 is 129. So to solve for angle A, I would subtract the 129, which would give me that angle A is a measure of 51 degrees. So that's what I mean by solving a right triangle. We just solved for the missing sides and the missing angle. Let's try another one. We have here two sides, but we have no angles. When you are given two side lengths, you can find for the missing side by using the Pythagorean theorem. Or you can always solve for any of these angles using inverse trigonometric functions and then use trigonometry to solve for that missing side. Remember that it does not matter what you choose to solve for first. I'm going to choose to solve for x by using the Pythagorean theorem. So that means that your legs squared added together has to equal to the hypotenuse squared. So 13 squared plus x squared is going to equal to 19 squared. 13 squared is 169. Plus x squared is equal to 19 squared, which is 361. Subtract the 169, and I get that x squared is equal to 192. Square root both sides, and we get that x is equal to, I'm going to go to my calculator now, because here when we're solving for these missing side lengths, notice that I told you to still round to the nearest tenth. So you don't have to worry about simplifying that square root. So I'm going to do the square root of 192, which is equal to 13.85, which rounded to the nearest tenth is 13.9. So that is that missing side. Now we're going to solve for these missing angles. I'm going to use the 13 and the 9. You can also use the 13.9 that you solved for here, but I typically like to stick to the whole numbers because you'll get a more precise answer since x was rounded. So to solve for A, the 13 would be the opposite side, and the 19 is the hypotenuse. The trig functions that uses the opposite and the hypotenuse is sine. So we would say that the sine of A is equal to the opposite, which is 13, over the hypotenuse, which is 19. Remember that when we're trying to solve for an angle, this is when you use the inverse of the trigonometric function. So A would equal to the inverse of sine of 13 over 19. So I'm going to go to my calculator here. Remember to select the inverse. You normally have to click the second button or shift button depending on your calculator. 13 over 19. And I get 43.17. And we are going to round these angle measures to the nearest degree. So 43 degrees. Since I solved for A and I get that it's 43, I don't need to use trigonometry to solve for B. I have two of my angle measures, and all three have to add up to 180. Now this doesn't mean that you can't use trigonometry to solve for B. You most certainly can, or you could have solved for B first. It all depends on how you saw it. But I like to do things a little simpler. Since all of these angles are supposed to add up to 180, that means that 43 plus the 90 degrees plus angle B is going to equal to 180. 43 plus 90 is 133. And if I subtract the 133 from 180, what I get would be angle B, which is going to equal to 47 degrees. And I have now finished solving for this triangle. Let's do a couple more. In this one, we have an angle measure. We're missing angle B, and we're trying to solve for x and y. I'm going to start off solving for x. Now, if I solve for x, I have this angle measure of 63. Y is the opposite side. X is the adjacent side. And the 34 is the hypotenuse. To solve for x, I would use the adjacent and the hypotenuse because this is the number that was given. Adjacent and hypotenuse is cosine. So to solve for x, I would have to use the cosine function. So cosine of 63 degrees is going to equal to the adjacent, which is x, over 34. To solve for x, I would multiply 34 to both sides. And I get that x is equal to 34 times the cosine of 63. So that's it. I'm going to go ahead and put that into my calculator here. 34 times cosine of 63. And I get 15.43, which remember that we are rounding to the nearest tenth, so my answer would be 15.4. So that is x. Now to solve for y, I have y here is now my opposite side if I continue to want to use trigonometry, and the hypotenuse is 34. So that would be the sine function. So sine of 63 is going to equal to the opposite, which is y, over the hypotenuse, which is 34. Now another way you could have chosen to solve for y is using the Pythagorean theorem, since you have two of the sides already. But I like to do trigonometry if I can. And again, there's no right way to do it. There's many ways to do it. So if you use the Pythagorean theorem, that would work as well. So I would multiply 34 here to both sides, and I get that y is equal to 34 times the sine of 63. So I'm going to go to my calculator. 34 sine of 63, and I get 30.29. Again, we're rounding to the nearest tenth, so this would be 30.3. Now to solve for the missing angle B, we already have two angles, so we can add these together and subtract from 180. So we get 63 plus 90 plus angle B is going to equal to 180. 63 plus 90 is 153. So subtract the 153 to both sides, and we get that B is equal to 27 degrees. Let's look at one last triangle. We have here two sides. We're missing both angles, and we're looking for this third side. I can solve for this third side by using the Pythagorean theorem, or you can choose to solve for your angles first and then use trigonometry to solve for x. Again, it's completely up to you. I'm going to choose to use the Pythagorean theorem. So I get these legs squared, so 7 squared plus x squared is equal to 25 squared. 7 squared is 49, plus x squared is equal to 625. Subtract the 49 to both sides, and we get that x squared is equal to 576. Finally, we square root, and the square root of 576 is 24. So x is equal to 24. Now we're going to solve for these missing angles, sorry. I'm going to start off solving for the missing side A. I have these two sides, or you can also use the x is equal to 24. You can choose any of the two sides, any two sides of the three, in order to solve for A, as long as you use the appropriate trigonometric function. So let's say I decide to use the 7 and 24. So I'm just going to choose random. The 7 is the opposite side, the 24 is the adjacent side, and the 25 is the hypotenuse, in case you wanted to label all of your sides. To solve for A, if I choose to use the 7 and the 24, that's tangent, since that's opposite and adjacent. So the tangent of A is going to equal to the opposite, which is 7, over the adjacent, which is 24. To solve for A, I would have to apply the inverse of tangent. So A is equal to the inverse tangent of 7 over 24. So I'm going to go to my calculator now, and I'm going to select the inverse tangent, 7 over 24, and I get here 16.26, which we're rounding angles to the nearest degree, so this would be 16 degrees. Now that we have A, we can solve for B just by subtracting from 180, since all of these angles have to add up to 180. So angle A is 16 plus 90 plus B equals to 180. 16 plus 90 is 106. So we can subtract the 106 from both sides, and we get that B is equal to 74. And now I have finished solving for all of those missing measures of this triangle. And that's how you solve a triangle.